Myself is BK Giri from Bodville College, Bodville, Odisha. Now I am going to present poster presentation about comparative study of electrical properties of BA5 SM TI3-X ZRX V7O30 and BA-GD TI3-X ZRX V7O30. The tungsten bronze structure has given formula that is A12, A24, C4, B12, B28, O30, where A1, A2 side filled by mono or divalent, B1, B2 filled by tri or pentavalent. Generally, the smallest intersect C is empty. So, general formula for tungsten bronze is A6, B10, O30. Then next we go to material synthesis. There are two type of material synthesis, that is material mechanical method and chemical method. In mechanical method we have to add mix oxide process or solid state reaction process. The sample preparation, the required amount of ingredient needed for synthesis of DGR compound was calculated from the reaction equation as follows. Then the flow chart of solid state reaction is given like this. Then material characterization, the techniques structural is studied by XRD, microstructure by SEM, electrical property, that is dielectric impedance by Aoki 3532, and polarization by hysteresis. Then next we have to study dielectric and polarization analysis. The dielectric study, the three important characteristics of dielectric ceramic relevant to their suitability for device application are relative dielectric constant epsilon r, which show the ability to store electrical energy; loss tangent, that tan delta, which indicates the ability of dielectric to support electrostatic field while dissipating minimum energy in the form of heat; and dielectric strength. All the results obtained from the experiment can be analyzed in the following way, that is variation of dielectric constant and loss tangent with frequency, variation of epsilon r tan delta with temperature. This is the frequency dependence of dielectric property, that is epsilon r tan delta with room temperature. This is the frequency dependence of dielectric properties of BA5 SM TI3-X ZRX of second series at room temperature. Then temperature dependence of dielectric first series, that is with different frequency, and this is the temperature dependence of dielectric for second series. This is the polarization study, that is hysteresis loop of first series and hysteresis loop of second series. Then there is comparison of the value of Pmax to PR EC of two series in the table, which is given in the table. Then next we go to observation. From the graph, the following observation was observed. It was found that GD modified compound with no ZR substitution undergoes ferroelectric to paraelectric phase transition at 460 degree, but no anomaly is observed in SM modified compound. From the dielectric study, it is also clear that with increase in ZR concentration, the dielectric constant decrease for both GD and SM modified compound. Then next we study complex impedance. Complex impedance spectroscopy is an important tool for study the microstructure and electrical properties. It enables us to evaluate the relaxation frequency of material at a given temperature, which is the intrinsic property. The electrical response of material measure can be expressed in the following formula. This is the graph of Z prime and Z double prime. Z prime is real part, Z double prime is imaginary part of impedance, then the modulus impedance. This is the Z and Z double prime graph for high frequency, intermediate frequency and low frequency. Then the Z prime and Z double prime graph or Cole-Coulomb graph for first series. This is the Cole graph for second series. Then next we observation. In most of the sample, the concentration to the impedance is mainly from grain and grain boundary, whereas that of material electrode interface was insignificant. It is also observed that the intercept point on the real x-axis shifted towards the origin with rise in temperature, which shows that the bulk resistance of the sample decreases with rise in temperature, which may be related to negative temperature coefficient resistance. Then As Zr constant increases, the bulk resistance of the material increases at a particular temperature in the compound. Next, this is the third properties. Next, thank you.